Hello everyone. In today's lecture we will cover Proc Freq in SAS, and also we will see how it is easy to understand or classify any dataset with the help of Proc Freq. And we will also learn how we use Proc Freq to generate different types of output and how to get insights from any source data. Before we start, this is good that we can discuss what Proc Freq basically does. So Proc Freqs generate the frequencies, and at the same time it gives the percentage, cumulative percentage, and cumulative frequency also working. So let's start. This is an area from where I'm picking a small data set. So this is a small information of employee database on which we are going to apply our Proc Freq technique. So let's start with Proc Freq. So Proc, as we know, Proc is always a procedure, so frequency is also one of the procedure. So Proc Freq data equal to, so my data is sitting in SM library and the name of my data is EMP, right? So first we have to understand on which variable we want to use or want to apply the frequency. As I have already mentioned it, this is a good idea to use or choose dimensional data, right? So I'm going to use on job variable which is job only. So this is table and job. Run. Now this much is enough for frequency procedure to generate an output. So what basically happening here, I'm applying a Proc Freq on my data set and I'm applying a table, like this is a tabular structure, this is a supporting keyword in Proc Freq. So it is not it's not like this that we can write anything. For example, if I have to classify, so this is not going to work here. So we have to understand what keyword is supporting and that purely based on the frequency type. So when we are using Freq, we use table instead of var or class. So let's start. Let's run this and see the output. Now see, as we have applied on job, so we have these are the job types: analyst, clerk, manager, president, and salesman. So more or less this is giving a small idea about my organizations, like how many job profiles we do offer and how many people are under these job profiles. So based on this report, we can easily understand that we have two people as an analyst, and we have 4 clerks, and we have 3 managers, and we have only 1 president and 4 salesmen. Now if you can see, we got percentage and cumulative frequency and cumulative percentage at the same time. So this is basically distribution of my data based on percentage. So this much percentage is occupied by the analyst in overall in my data. So clerks, clerk, they are capturing this much of ratio when I'm talking about percentage. And president, as we can see, we have only 1 president, so the contribution of the president in whole organization is around 7%. And more or less, if we can see, clerk and salesman, they are contributing higher in terms of percentage. Now cumulative frequency and cumulative percentage, what does it mean? This is for frequency, and cumulative percentage for this percentage. So what basically at the very first line we got 2 numbers, like as in frequency for analyst, and when we moving down, so we have 4 at the place of clerk. So in total we have 6 at this level. So this is very easy to understand. If we can include analyst and clerk, so how many people are basically, so at this level there are 6. So this is the addition. So what cumulative frequency means is here getting the addition at every level. So if you can see, the addition of 2 and 4 is 6, and now here we are including 3 by including managers, so the figure is 9 in case of cumulative frequency. Likewise, the same logic is applying on the cumulative percentage also. while we can add up 28 and 14, we will get 42, and at the end we will always get the 100% because this is the overall total of the distribution. Now in this case it's showing 14. Let's see how it is coming 14. So if we can see, let's say proc print data, this is not a good idea to see the count, but I'm just showing it just because the data size is very small. Otherwise we can use means or other procedures to get the count, right? So now you see this n equal to 14, that means we have total 14 employees under this organization. So as we have seen in procedure Proc Freq output, that it's here, that the count is 14, right? So this is very easy to understand your data with the help of Proc Freq. That Proc Freq basically classify the data and whatever you are applying on. Let's apply the same thing on department number. Here I'm going to take this off and we will write department number. So what the idea is here to understand, I want to see the number of I want to see the population based on department number, like how many people are in each department. So this is a good idea to apply Proc Freq to generate such kind of reports. Now see this. We have 3 people under department number 10, and we have 5 people under 20, and we have 6 people under department number 30. So after reading this output, we can easily say almost 40% and even more than 40% crowd lies under department number 30. So this is the crowded department, right? So we have a very less people that comes under department number 10. As we have already the output of this, let's see this. Yeah, so we have only 3 people, including president also, in department number 10. So more or less this is not a department of production or sales, where I can see in department number 20 we have 1 2 3 4 5. Yeah, we have 5 people under department number 20, and in department number 6 we have in 30 we have 6 people. 1 2 3 4 5 6. Fair enough. So this is the overall contribution in terms of percentage all across the department we have in this organization, and this is how the cumulative frequency and the cumulative percentage is. What if we just want to see the count other than this additional output? So we will basically restrict the output by using a slash, then we will mention that I don't need no cumulative, so we don't need the cumulative, and also no percent, or no percent for not getting the percentage. So now see this, only the count of each department, right? So let's go back and use the same technique on 2 variables to classify the output. Now see this. Now this is the raw data. Let's generate a query where we want to see how many people, as in a job, like how many managers in each department, and how many clerks are there in each department. So how we can generate an output if we have to understand how many people are based on the department number. So if we have to see whether all the analysts are belongs to a same department or are from different department, and likewise we love to see based on job to department number or vice versa. So let's take an example for cross tabulation. So what basically we are looking here, department and job wise classification or segmentation. So let's say department number. So what basically I'm doing here, that I'm using an asterisk here in between these two, and what if we'll not use it. So this will generate the two different output, one for job and one for department number. Let's see. Now see this, this output is for the job and this output is for the department number. And when I have to merge all these two tables, so what we will do, we will use an asterisk in between. So what will this does, that it will create one cross tab where we can actually easily figure out the number of jobs based on department number or vice versa. Let's run and check the output. Now see this. Let me first control the output so we can easily understand this by putting some restrictions. Basically, no cum for not getting the cumulative, no percent for percentage, no row, as we get the row calculation and column calculation. So no call, right? So now see the output. Now this is what the idea was. We have cross table for job and department number. If you can see, these are your job types available in your organization, and these many are the department numbers. So when we talk about analyst, we do not have any analyst in department number 10 and 30, but all are in department number 20, and there are two as a number. Analyst, there are two in number, and this is the total. And for clerk, we have 4 clerk. Now this is a catch, and to understand this, now every department has 1 clerk, but in department number 20 there are 2 clerk. So this is something to spot on and to stop on, like why there are 2 clerks. Now this way it's very easy to understand a data, right? Now this shows a very fair data that every department has one a manager, which is fairly enough. Like it's good to see this. Otherwise, if there are more than one manager in any department, so that can be easily identified from this report. So I'm least bothered about this one. Now we have a one president, which is in department number 1. That's okay. Now salesman, we have total 4 salesmen, and there are no salesmen in department number 10 and 20. So there should be some logic behind that's need to be worked on, but it's okay for me. And we have 14. Now this is very important to understand. If you do the total calculation from here, you will get 14, and even if you will do it from here, so you will get the 14. So that's mean this is your department wise total, and this is your analyst, if you will say, this is job wise. So cross we generated the cross tabulation, where we actually can see how the number are spreading all around, right? So Proc Freq is very helpful to identify, to understand or do the classification of data, where we can actually see how they are coming in terms of percentage and in terms of numbers. So let's take this all off, because we understood the short summary. Now I want to retain all of them and see what does it mean. Now we are not restricting, and we are populating every information under the table. So what basically 4 values these are. For the first one is for frequency, then percentage, row percentage, and this is column percentage. So this is account, that we have 2 people under department number 20, right? So the another value is for percentage. So they are occupying, they're utilizing this much, they're contributing this much. And now row percentage, when I'm talking about row, so row is this, like horizontal. So row percentage, that's mean there is no contribution from department number 10, and also not there is no contribution for department number 13. So this row from, like in this row, department number 20, this section is contributing by 100%, right? So this 100% is not dividing and spreading all around. in these three sections, but everything is coming under the department number 20. So the raw percentage for this particular section is 100%. Now come to the point, column percentage, 0, 0, and now this is 40. Why this is 40 is just because we are talking about a column percentage, which is a vertical thing, like this is a column. So the total should be 100 in like when we aggregate actually. So when it's showing 40, so that's mean some other than the like some ratio is also spreading all around. So we have to understand how this 40 is. Now again 40 is here for clerk. We are just reading this out, we are just discussing this out, do not look any other figure. So we are talking about column percentage, so which is 40 in this case. Now again 40 here and now 20. So if you can add them up, you can get 100%, which is 40, 40, 80 and 20. So no contribution in this one and this one. So that means how you are contributing in terms of your column. So like when we talk about department number 20, so we have 2 people as an analyst, 2 people as in clerk, and 1 in manager, and now we don't have president and salesman in department number 20. So that's mean in this particular column we are contributing with analyst and clerk and 1 manager. And if we can actually break them down in terms of percentage, so they are occupying 40% out of 5 people, and 40 again for clerks and 20 for manager. So this is what all these parameters are. So if you can randomly pick any value or any cell, you can actually understand what the figures are all about. So let's take this one. So when I'm talking about upper section, which is 1, and this is a frequency, that means you have only 1 president and it belongs to department number 10. And this 7.14 means your percentage. So this is your overall percentage for this department number 10, because you are contributing with only number 1. Now row percentage is your 100%. Again this is a raw, no other department is contributing in this figure, so it's all coming under this section, and this is 100%. Now when we talk about column percentage, so this is your column, and in this section you have 1, 2, 3 people under this column. So if you can see, they all are contributing with the same set of percentage, basically equally divided. So when we will add them up, we can get 100%. So this is the overall idea and the picture of proc frequency. Let's take another one, another data to understand and with the help of some other data. Okay, let's take this data. This is again a very small data, no worries. For example, we have to classify based on sex. So what we will do, basically proc freq sorry, data equal to this data is available in SAS help, and the name of data is class, and we are going to generate table on sex variable and run. So you should know how the output, before running this you should know how the output is going to populate. So basically output will be in 2 section only, or whatever you have under this section. So more or less we have 2 types of sex, male and female, M and F. So we are going to get output based on M and F. Now run this. Now see this. So you have in total 19 people under this data set, and out of this 9 are female and 10 are males, right? So the data was very small. Let's take the another data again. It's a kind of same DM tool group. Let's take let's take this data. Fair enough. So we can, let's take the status. This is status. Yeah, okay. So I'm going to work on heart data set, and we will first start with the status, and this is again available under the library of SAS help. We just need to change the name of the dataset, which is heart. Yeah, so status is a variable on which we are working. Now see this. Now based on this output we have two status, alive and dead. Okay, so we had 5209 people, and we have this much like information of these many people, and out of these by 61% people are alive, and we have 38% people they are dead. Oh, that's bad. Okay, yeah, that's why we say it's very important to take care of your health. Yeah, so now let's understand their sex type. So how many were male and how many were female, right? So what we will do, we will use sex column. Yeah, let me check. Yeah, this is sex. All right, so run this to make a better output. Let me use these. Let me control my output. Okay, otherwise we know if we want we can not specify these things, right? Now see this, female, male, and this is your total figure, and alive and dead, and this is your total figure. So this was the actual figure, as we have seen, 5209, 5209. Now look, out of 3218, which is let me generate the another one also. Yeah, now we can easily compare the output. Now see this, we were discussing this table while we had 3218 as an alive. Oh, this was not the output. Status, yeah, let me change this status. Oh, something is wrong. Oh, okay, heart. Now see this again, let me generate the last one. Now 3218, they are alive. Now I don't know their distribution as in male and female. So here 3218, out of this 1977 are females and 1241 are male. So out of this the ratio of alive people is higher in terms of like in like for females, and when we talk about for dead, we have total 1991. This is your dead number of people. So they are divided in as we are working on male and female. So now they are lesser in case of female and higher in case of male. So if we can see the data is reciprocal, we have a higher rate of alive in case of female, and when we were studying for dead, so there are number is higher in case of male. So this is easy to identify, like how many alive and dead person are there in this database, and how they are, like were they female or a male, and this way it's very easy to identify them. Now go back to the dataset again and look for more opportunities if we can do that. Now we can see the cause of death. Let me take the exact name of this variable. Now we will include this parameter also. So what's the cause of death? Now see this. This is a table of table 1 for sex by death cause. So we are controlling the status for alive, and just this is the missing frequency, that's mean missing value, that we really don't know these death cause for these many people, right? Let's see this. actual the number is this much higher. Yeah, so these are the blanks, right? So they must be in that number. Anyways, so what basically happening is here, female, when we talk about a female, so 250 females were died by the cause of cancer and cerebral vascular diseases. Because of this disease, 199 females died, and heart diseases, out of this 209, and 176 with some other ailment, and for 56 we really don't know the reason. So this 56 is basically in this case of female, right? Again the same figure is 56 in case of unknown, like we don't know the reason of their death. So 1991, 1991, if you'll see, the dead figure is 1991. Let me pull the another output result. Now this is death cause of sex 1 and this is for sex 2. Wait. Why I'm getting same output? Oh, basically the other table is here. Yeah, now see this, this is death cause and the status is alive. So when we say alive, so how, like, there is no point of discussing this because the person is alive. So again they must be missing with these many numbers because they are alive. If you can see this 3218, 3218, so that's mean there is no specific reason of death based on some ailment, is just because they are alive. Now go back to your data set and see. Now wherever you'll see this blank section, that's been missing thing, so you will actually see they are alive, which is a good thing. Yeah, so definitely cause of death. So when we write something cause out of this, so this status should go wrong because there is a reason of death. So that mean indirectly we are saying that the person got person got died because of this reason. So how can we say he's alive? So when we are saying alive, so of course it should go as in blank, right? So it's fair enough. Now just so in total we have 3218 and 1991. So we created two different table, one for alive status and one for dead status. So I hope you understand this a procedure in a good way with these examples, and at the same time I would recommend you guys to pick up other data sets and put your insights, like first generate your queries, what basically you are looking for, and then apply the procedure to see the output, how it is coming and how it can be utilized to summarize the data and to understand the data in a better way. That's all for this video. I hope you enjoyed. Thank you very much.